We're going to talk a little bit about the biological control of corn rootworm with native New York entomopathogenic nematodes. Now, entomopathogenic, sometimes in this talk, you'll hear me talk about biocontrol nematodes. I use those two terms interchangeably. For those of us that stuttered as a kid, entomopathogenic sometimes gets to be quite a mouthful. This slide really shows the entire talk in one slide. On the left, you have a failing BT event, and you have major corn rootworm larval feeding injury. This came out of my plots in 2020. On the right, you have the same exact BT event variety. The only difference is persistent New York entomopathogenic nematodes were applied in 2014, and they have persisted in the plot for the past 7 years, killing corn rootworm each and every year. So let's dive a little bit deeper into nematodes. Now, nematodes there's about estimated 1 million species worldwide. There are 28,000 that have been identified, 16,000 species that are parasitic. Now, they're all very specialized. So we have free living ones that live on organic matter. We have plant parasitic nematodes, which we deal with in agriculture all the time. And we have animal parasitic nematodes, which, human health, animal health is involved, and entomopathogenic nematodes are among the animal parasitic. So to bring this in a little sharper focus, plant parasitic nematodes, if you are soybean growers, are dealing with soybean cyst nematode, a very specialized nematode that attacks soybeans and its close relatives. Our vegetable growers are dealing with root knot nematode, another specialized nematode that only attacks plants. We have some human vectored nematodes. In the tropics here, we have Elephantiasis, which is a nematode that's transmitted by mosquitoes that plugs up your lymph system and causes this intense swelling. Heartworm on dogs in much of the United States, those of us that are dog lovers have to treat our dogs to prevent them getting heartworm, which is another nematode spread by mosquitoes. And we have nematodes that live in our GI tract and the GI tract of all warm-blooded animals, farm animals, dogs, including humans. So ascaris, hookworm, and pinworms. But what we're really talking about is a specialized nematode that attacks only insects, entomopathogenic nematodes or biocontrol nematodes. They're obligate parasites of insects. They're naturally occurring in the soil. They hunt out their host and kill it and reproduce within the cadaver. And the ones that are swimming about the soil profile are completely non-feeding. So EPNs or biocontrol nematodes have been isolated from every inhabited continent in virtually every type of soil habitat where we've made a concentrated effort to look for them. So that raises the question, why then are the native entomopathogenic nematodes not an effective natural biocontrol in agriculture? I mean, if they're found everywhere, how come they don't help us out? And the answer is there is a mismatch between the entomopathogenic nematode species that evolved in each location and the agricultural pests that move in when we convert the native habitat to agricultural fields. The species present is very important because species differ in their soil profile preferences and their hunting strategies. So here's an example of the 3 most common entomopathogenic nematodes. Sarnema carpicapsi is only happy in the top 2 or 3 inches of soil. It's an ambush sit-and-wait nematode, so it waits for the insect to come by. And in the Northeast, it is the most common of the nematodes if you go out and sample and look for them. It evolved in primarily white pine forest. Sarnema feltii is both an ambush and a cruiser. They both sit and wait and they hunt. We only find them in isolated pockets in the Northeast, but they actually operate in the top 8 inches of the soil profile. Heterodytes bacteophora is a cruising nematode. It's hunting for its prey. And we find this in isolated pockets in the Northeast, primarily in sandier soils because this is a larger nematode and needs the larger pore size to move about. Nematode species mixes enhances their effectiveness, and this has been some of our research. So if you are dealing with the heavier soils, clay loam to loam soils, we have found that you mix Carbocation and Feltii together, they're very complementary to each other. Carbocation rules the top 2 inches. Feltii fills in wherever Carbocation is not. If you're talking about the lighter soils, say the loam to the sandy loam soils, the mix that seems to work the best is Feltii and Heterodytes bacteophora. The other thing I want to address before we get into data is the difference between commercial strains and native persistent strains. Now, commercial strains are the ones you can buy on the internet. You can take the 3 species I just showed you, you can dial up on the internet, and you can find suppliers to sell you those species. Those are commercial strains. Commercial strains do not persist past 7 to 60 days, and that's being very generous, about 60 days in the field. It's usually 7 to 30 days. The reason is the genetic ability to persist has been lost through the continuous rearing under artificial conditions. So since it does not persist, you are required to have accurate application timing to be effective against soil pests. So, and then it's highly variable in quality because oftentimes they have been stored too long and you don't get nematodes that are completely alive. So commercial strains of EPNs require multiple applications during a growing season for extended protection, and they require application every year. So that's your commercial strains. Those are the ones that are easily available no matter what species. You buy them on the internet, you know, they're commercial. Now, in contrast to the native persistent strains, which I've worked with, and the rest of the data is focused on these, they persist in the field after single application for multiple growing seasons. Now, the reason is their genetic ability to persist has been retained through very careful, unique rearing techniques. The native EPNs can be applied anytime soil temperatures are above 50 degrees Fahrenheit. Since they persist a long time, you don't really have to time. They will be there if you apply them before the pest. They will be there during the time the soil insect is there. Once established, they're always active and reproducing in the soil insects that are present. So in summary, a single application provides pest insect control for multiple growing seasons. And once established, your native persistent strains are always active, always searching out prey and reproducing in the soil insects that are present. And how do they do this? Well, it's kind of interesting. They have what they call phased infectivity, and which means that not all the effective juveniles in the soil are infective at the same point in time. Some of them are in a suspended animation and they become infective at some point down the line. We've discovered it's genetically based. If you are not careful, it's lost in continuous rearing, and it's completely absent in almost all the commercial strains that we've looked at. So how did we stumble onto this technology for rootworm biological control? Well, New York. Most people think New York is all city and asphalt and concrete. But in fact, we have population centers of Buffalo and New York City and a couple in the center here, and the rest is agricultural. New York is the 3rd largest producing dairy state, and there's lots of agriculture, lots of corn, lots of alfalfa. And New York is the home to a very serious insect. The entire North American infestation of alfalfa snout beetle is this area of New York and a little bit in Canada. Now, alfalfa snout beetle kills alfalfa out in a single year with its root feeding, and alfalfa is a critical component in the dairy industry. So very early on, we discovered in the research to try and control snout beetle that EPNs are very effective in protecting alfalfa and killing snout beetle. You can see the dead areas with snout beetle. So fast forward to 2020, we have more than 28,000 acres inoculated with biocontrol nematodes against snout beetle. It's on more than 130 farms and it's expanding every year. Alfalfa stand life has increased back to 4 to 6 years rather than 1 to 2. In the fields that have been treated, snout beetle has disappeared, and we have helped Mary DeVere create a business to continually supply these nematodes to the farmers of New York. So in the process of this research, trying to answer farmers' questions about how often do we apply, we studied persistence across rotation. So here's an example. Here's the nematodes were applied in alfalfa in 2008. 2009 was alfalfa. It was rotated, the field was rotated to corn in 2010, and you can already see the increase in nematode population. Second year corn, where rootworm moves in, we got this huge increase of nematode population and then maintained for the next 2 years. This is indirect evidence against activity against corn rootworm. So based on this evidence, we then in 2014 initiated a special trial to look at EPNs and corn rootworm. And we did this by having 3 treatments: no EPNs, the mix of Cyanoderma carpocapsae and feltii, and the mix of feltii and heterobidites. In each of the corn blocks, we then planted 6 rows of conventional, being the non-rootworm variety, 3BB1 or Yield Guard, 3435 and Herculex, and Smart Stack. Now, before I show you some data, let's talk about damage ratings. So the Iowa 0 to 3 damage rating at somewhere between 1/2 node and 1 node damage, depending upon the year, is where the economic losses begin. If you have a dry year, it's less. A wet year, it's more. Okay, so we applied nematodes in 2014. 2016 was our first economic infestation. So let's look over here under the non-rootworm BT. The blue line is without nematodes, and you see that we have 1.9 nodes gone. Call it 2 nodes gone. You add nematodes to the conventional, and you have less than 2/10 of a node gone. Excellent control. If you look at the other way here, you see that our nematode by conventional mix gives equal control to all of our GMOs. So we applied nematodes 24 months before in 2014, and we have excellent control 2 years later. Okay, so that was 2016. Here's 2016. What has happened since 2016? So here we start with 2016. Here's without nematodes, 1.85 nodes consumed in our non-rootworm traded corn. With nematodes, it's 2/10. 2017, we had light pressure. So here's 4/10 of a node versus 1/10 of a node with nematodes. 2018 was an extremely wet year, so we didn't have any rootworm pressure. 2019 was a drier year. So here we have a 1/2 node without nematodes, a 1/4 node with nematodes, so we got below economic. It's not as good a control as before. We had cages in the field for adult emergence, and it got very dry in the cages. And in the cages, we had 2 nodes that were damaged by rootworm without nematodes. And with EPNs, we had a reduction, but it was still economic. Nematodes require the film of water on soil particles to move about to find their prey. And so in very dry soils, this obviously was absent. So we saw a reduction of efficacy. In 2020, a more normal year, you see we're back up to 6/10 of a node. It's pretty moderate, light to moderate pressure. With nematodes, we're at 0.1. And in the drier conditions of our tent, we see similar results. So what about traded corn? So here's 3435. And the reason I picked this is this is an example of the rootworms over the years becoming a little resistant to this trait. So here's 2016, no advantage to having nematodes. Okay, the GMO, the trait was holding. 2017, we didn't have any pressure. 2018, without nematodes, we're talking about more than a 1/2 a node that's damaged plus nematodes 0.1. 2019, here's a full node now that is damaged without nematodes. You add nematodes to it, you can see that you reduce the damage by 82%. In the same situation where in cages where it's extremely dry, here's 2 nodes that are damaged with nematodes. There's 1 node. This is still an economic loss, but this is an indication that dry soils may reduce efficacy. 2020, 1.1 node, 0.2 with nematodes, excellent control. Within the cages, excellent control. So what this is beginning to show us is that under very dry conditions, we may have some serious efficacy problems. Of course, the corn isn't doing too good either, but you know, that's the first indication. And even with traded corn, you can see that failing traded corn in very dry conditions, we're seeing some suggestions about efficacy problems. So that raises a question: how are these really going to survive in a drought? Well, in a joint study at Penn State with John Tooker, this in 2020, he had extreme drought conditions. So if we look, the year of application was 2019. You see no difference because, you know, there was not very much pressure. 2020, he had extreme drought during the larval period, 3 inches in June and almost no rain in July. So with our BT rootworm trait, without nematodes, you still had 1 full node gone. So the plant had difficulty generating the BT. Nematodes didn't help much. The non-BT, we got no efficacy out of the EPNs because they couldn't move about. However, the EPNs remained there at 50% of occurrence. So they survived the drought. They will be there next year when soil moistures become more normal. So in summary, you know, established biocontrol nematodes provide 50 to 90% reduction in rootworm feeding damage 2 to 6 years after a single application. Dry soil conditions during rootworm larval period can reduce their efficacy, and they appear to be completely compatible with our BT rootworm technology. So what about persistence? Can they persist under continuous BT rootworm corn? Well, here's a graph. And what we have here are 2 graphs. One is smart stack, where we expect to see 1 adult per square foot emerge, and conventional corn, where we expect to see 18 adults per square foot. Here is our 2016 serious damage. And on the bottom here is fall of 2014 to the fall of 2020, last fall. And on your left axis is the percent of soil samples positive for EPNs. And what you see, the takeaway message is both of these 2 lines track each other, whether it's in smart stack and whether it's in conventional. So what are they living on in smart stack? Well, we think that they are actually attacking the intoxicated larvae, rootworm larvae, before they die. Okay, so much for New York. 2 of my colleagues in Texas, Pat Porter and Ed Bynum, found this data interesting and said, hey, come on down. So off we went to Drought, Texas to work with them. In that area, most events were having difficulty. Many farmers were using soil insecticide at planting, and some farmers were using 1 to 3 foliar applications, beetle bombing, to try and reduce the adult population. So Dalhart is center pivot. The farmer that they had volunteered to let us to host the plots, Gary Frost, had a 500-acre center pivot. And here the plot went out in 2017. The field had been continuous corn for many years. BT corn was experiencing damage. Soil applied insecticides were needed plus BT. The application was made in May of 17, and it was made with a backpack sprayer. And here is Caitlin Keschheimer, who used to work with IPM in Texas, and she's now at Auburn, actually going out and applying the nematodes to the plot. back to our rating scheme to remind you, no damage between 1/2 and 1 is where we call about it the difference between economic and subeconomic. Well, the farmer planted completely susceptible non-rootworm corn, and you can see that our damage level with nematodes is still economic, 1.8, but it was quite a bit lower than the untreated at 2.3. Now, this is year 1 data. I've always said that it takes 2 years to get fully distributed. The people who rated the roots said, well, the difference was we got beautiful root, and one that got reamed. And you can see that. See, here's one that has quite a bit of damage. This one looks really nice. This one looks really nice, compared to every one that looks pretty tough. So that's a distribution. So the nematodes did not have time to completely redistribute from the application in year 1. But we were thrilled with the results. So what about persistence? Here is, they were applied in the spring. We're talking about 1 out of every 4 soil samples were positive shortly after application. In the fall, that jumped up to 1 out of 3, or 30%, being positive. Over the winter, we had some redistribution going on, and we were actually looking at nearly 50%. 1 out of 2 soil samples were positive for biocontrol nematodes. The farmer planted 34-35 that year versus conventional, and so we didn't see any difference to rate roots. The fall, we were still hanging in there at 50% of the soil samples positive for nematodes. And in the spring of 2019, we hang in there with 50%. So we got excellent persistence at that location. In the other nematode combination of Carbocation feltii, you can see that the rating is a little better, but it's still not subeconomic. But there's still quite a difference between the untreated checks in year 1. If you look at persistence of these two, you see a similar sort of thing of, 50%, but here comes in a native heterobidites that we did not apply. Genetically, this was a native species, not the one that we applied. So we didn't detect it before the study, and here it comes to help us out. So bottom line is, after 2 growing seasons, we are at 50% total nematodes. Excellent persistence. One of the reasons we ended the study was contamination of the untreated checks. And so here it is, heterobidites, a natural native heterobidites has come in, and so that confounds the data. Based on the persistence data, the reduction in damage in this field, the farmer then treated the 200 acres of the pivot that had the worst problem in May of 2019. So off we go a little further south to Roswell, New Mexico. Pat Porter and I went down there. They have serious event failing problems. Farmers with problems are the dairy operations that grow continuous corn under irrigation. So typical of New Mexico, your agriculture are in valleys where you have water. So here is the Roswell, Dexter, Artesia Valley. And here's the dairy operation, 126 acre center pivot. And the history of that field is it was long-term continuous corn. The yield expectations were 35 to 40 tons per acre silage. In 2018, there was a major event failure resulting in a 35% loss. The yield was down to 25 tons. So the farmer was more than willing to apply biocontrol nematodes, and we applied them through the center pivot. The way we applied them through the center pivot is we took one of the totes that are found on every farm, and we created a nematode solution of the right concentration. We bubbled water in this concentration so the nematodes remained alive during the 14 hours of the application. They were injected through the chemical injection pump at the well, or at the base of the pivot, and it was calibrated for 25 gallons the hour. So if you run this pivot at 100%, it's a 1/4 inch of water. So you're applying nematodes in over 6,000 gallons to the acre. It required 14 hours to apply to this entire pivot. And you can see there's pretty good water concentration to apply nematodes. So the question is, how well did the application work? So in the fall of 2019, we headed back to take numerous samples with GPS readings on transects across the field. So here's the data. So the pivot, the application started about here on the southern transect, went counterclockwise around, and you can see that each of the transects have very similar levels of nematodes, 56, 52, 45, 57, 42, 50, all the way around the circle. So it appeared that we got a very even distribution. And this measurement is 166 days after the application. The other concern was, since they were injected in the center, was it an even distribution based on the rings? And you can see at 55%, 49, 49, and 45, that we got a pretty even distribution. So we were very pleased with the distribution. So this is the fall of 2019, 166 days. Spring of 2020, COVID issues and all, we got back there to apply, to actually sample. So this is 340 days after application, roughly a year. And you can see that we still have very high levels, 48%, 48%, 54, 54. This side of the field seems to be lower. This is a lighter soil part, but we had very good persistence. And then we went back this past fall with 530 days after application, so it's a year and a half. And you can see that the levels of 46, 50, 36, this is a little low at 28. We're still seeing persistence, 2 years later. And some of this variation is just sampling error. Okay, so we got persistence. What about yield? So the farmer's expectation was 38 to 40 tons of silage per acre. In 2018, the failed BT rootworm, he got 25 tons. So that's a loss of 13 tons, value of $38 a ton, $500 an acre, or a loss on the pivot of $62,000. In 2019, the same failing variety was planted. Liquid insecticide, soil insecticide at planting was added, and we applied biocontrol nematodes shortly after planting. Result, 38 tons to the acre. In 2020, same failing BT variety plus the nematodes that were applied in 2019, 1 year prior, yield 38 tons to the acre. So it appears that the biocontrol nematodes counteracted the failed BT and actually brought the yield back up to the farmer's expectation. So this year we decided that, well, let's try it somewhere else. So off we went to Western Nebraska with Julie Peterson, and to see whether we get persistence and we can apply through a center pivot in Nebraska. So this is located on the Hahn farm in Paxton, Nebraska. Here's the field at the spring sampling where we were looking for native nematodes. The biocontrol nematodes were applied in June of 2020. The fall sampling indicates we had establishment in more than 50% of the soil cores. Excellent establishment. So we will get back and sample this in the spring of 21 and then look to see whether we get enough rootworm to actually look at efficacy. The real question, the first question is, will nematodes persist? Will these persistent EPNs persist in a wide variety of environments? So with my colleagues around in various states, we are actually looking at that. So You know, more than 20 years in New York. Well, they originated in New York. 2 year study in so far in Penn State, 1 year in North Carolina, 2 years in Alabama. And these are the age of the studies. 3 years in East Lansing, Michigan, Northeast Iowa. We started the study this year. 4 years in Columbia, Missouri. 1 year at Paxton, Dalhart, now 4 years, 2 years in Tucumcari on alfalfa, and 2 years in Roswell. So how else can we apply? They are very easy to apply with a commercial pesticide sprayer. You remove the screens and filters. You use a stream type nozzle, so you can shoot a solid stream down on the soil surface. You apply at least 50 gallons of the acre, so you get a wetting of the soil surface. You apply late in the day, and this method has been used on more than 30,000 acres in New York on alfalfa and corn. And here's one of my Western New York dairy farmers who is filling up his sprayer and to apply to 200 acres for corn rootworm control in New York. This happened. This is a picture from the spring of 2020. One of the other interesting ways to apply it is in liquid dairy manure. This is Mike Hunter. He's one of my extension specialists that I work with. He was on my case for years to try the liquid dairy manure. I didn't think it would work. I thought actually it was a ploy to get me to stand behind the tanker and somebody was going to hit the switch and cover me with manure. But in fact, it works beautifully if you can get you dump them in the tank and your field application happens in less than 30 minutes. Apparently it's an oxygen deprivation system and they can survive in low oxygen for about 30 minutes. It takes you longer than 30 minutes and you start getting death. You get a beautiful UV block with all of the solids of the manure. You get lots of water. It can be applied any time of the day, and the farmers are going over the field anyway. It's no extra trip over the field. So where do biocontrol nematodes fit in U.S. corn production? Are they a standalone for conventional corn? Absolutely not. They must be used with other rootworm management tools because rootworms will develop resistance to nematodes as a single mortality factor, just like they have to everything else we've thrown at them. They're compatible with our GMO technology or rootworm technology. We think they will increase the durability of these events by killing the survivors and reducing resistance development. They may be a mitigation tool. We aren't sure. We need more research. But in some cases, about 30% reduction of adult emergence from the trait alone. What does it cost? This is a one-time cost, $50 an acre, plus shipping cost, plus application cost, depending upon how the farmer decides to apply it. So $50, multiple years persistence. So we're used to depreciating costs. So if you depreciate it over 5 years at $50 an acre, that's $10 a year. If you're raising silage, that's less than a half a ton of silage, about 1% yield loss. The problem with rootworm is that 5% yield losses are usually unnoticed. A 5% yield loss is $61 the acre. So if you're protecting 5% yield loss, you paid for the nematodes in 1 year. Similar about grain production. You know, it's about, for $10 a year, it's about 2.5 bushels per acre at $4, depending, of course, about your yield. But a 5% loss is about $40 the acre. So 1 to 2 years, you pay for the nematode cost, and this is a one-time cost. So where do I get them? Well, there's a company that I've helped come up to speed, Persistent Biocontrol, that it has been selling these nematodes to interested farmers. Here is their webpage. I have been providing some nematodes to farmers early in the process. And don't write these down, they'll be on the final slide for your reference. So in summary, established biocontrol nematodes provide 50 to 90% reduction and rootworm feeding damage 2 to 6 years after they're applied. Dry soil conditions can reduce efficacy, and biocontrol nematodes are completely compatible with rootworm technology. Now, there's a couple of consultants in the Roswell area, Bart Getz and Justin Boswell, who have agreed to answer your questions if you have questions. And here is their contact information. They've watched these experiments, and if any of you know Bart and Justin, you know you're going to get the straight scoop. And in fact, if you catch them at the right time, you might even get them to admit that when they first heard about this technology, they thought the old boy from Cornell had been smoking something in the streets of New York City. So I finish up with the same slide. Here is rootworm damage, failing BT event. Here's the same event. The only difference is nematodes were persistent, EPNs were applied 7 years before and are still killing rootworm. Now, I want to talk about one slight more subject. My interest in working in New Mexico was actually white fringe beetle, attacking the #1 New Mexico crop of alfalfa. It is so similar to alfalfa snout beetle that I'm pretty convinced that these same nematodes will work as they did with snout beetle. And so we're continuing to work with the New Mexico state people to try and get the research going. I would like to acknowledge my cooperators, the 150 New York participating farmers that actually applied nematodes before I had all the answer. And together we have figured out much of what I've presented. The funding by Northern New York Ag Development Program, New York Farm Viability Institute, Cornell, and Cornell Ag Experiment Station. And with that, I will answer any questions. Certainly, here are the contact of Bart and Justin, the source, persistent biocontrol, and my email if some people have questions.